Hello guys, welcome back to my channel. Please remember to like and subscribe. Now today we're going to be looking at integrating a linear function raised to a power. Now on screen we have the integral of ax plus b to the n dx, which means that a and b are both constant. Now of course when we were doing differentiation, if we had seen something like this, then we would have applied the chain rule. With integration, we're going to be applying a similar concept. The problem here is that we have a function raised to a power. And that is going to create some problem for us because we're not used to seeing the integral like this. So to make it simpler, we make a substitution. So we can go right ahead and say, let u equal ax plus b. Now here's the problem. If I'm going to change the function to u, then I can no longer have dx. I have to have du. So we're going to have to differentiate this function. So we can say du over dx would be equal to a. So we can transpose this function for dx. So we can say that du is equal to a dx, which means that du over a is equal to dx. Now let us go right ahead and rewrite the function. So this becomes the integral. We're going to replace the ax plus b with u, so you have u to the n times the dx now becomes du over a. Now, because a is a constant, we can pull that outside of the integral. So I'm going to have 1 over a times the integral of u to the n du. This becomes 1 over a times u to the n plus 1 over n plus 1 plus a constant of integration. And if we wanted to tidy that up a bit, it would actually become u to the n plus 1 over n plus 1 times a plus a constant of integration. However, bear in mind that this was a function of x. So now we're going to have to say, recall that u is equal to ax plus b, which means that this integral becomes ax plus b to the n plus 1 over n plus 1 times a plus the constant of integration. Now, by looking at this integral, do I really need to go through all of this? Or can I make a deduction from this? Because notice what really happens here. We have ax plus b to the n plus 1, which means I added 1 to the power. I divided by the new power, which is n plus 1. And of course, you see n plus 1 times a in my denominator, which means I'm multiplying the new power by the differential of the bracket, which is a. So that is actually an interesting thing to look at there. So if I were to summarize this, I wouldn't necessarily have to go through that entire step. We could simply make a deduction here. So we could say that the integral of a x plus b to the n with respect to x simply equal to ax plus b. What we do is to add 1 to the power, so we have n plus 1. We divide by the new power, which is n plus 1, multiplied by the differential of the bracket, which is a. And of course, never forget, your constant of integration, which is plus c. Very critical. Alright guys, we're going to look at 3 examples. Now, starting with question A, the first thing we want to do is to recall the general rule. So recall that the integral of ax plus b to the n dx is equal to ax plus b all raised to the n plus 1 over n plus 1 times a plus a constant of integration. So we simply add 1 to the power, we divide by the new power multiplied by the differential of the bracket or by the coefficient of the x. So applying that to question A, the power here of the bracket is 4. So I'm going to add 1 to that. So I'm going to have 3x plus 2 raised to the 5th power. I now divide by the new power, which is 5, times the differential of the bracket, which is 3. Or I can say times the coefficient of x, which is 3, plus my constant of integration. And if I want, I could tidy this up and say 1 over 15, 3x plus 2, all raised to the 5th power, plus a constant of integration. For question B, the same rules apply, but here we have a square root, and we know by laws of indices that this can be written as 2x plus 4 raised to the half. All right, and we care about the integral sign because we have not integrated as yet. Now the power is a half, so we add 1 to the power. So I'm going to have 2x plus 4. I add 1 to a half, I get 3 over 2. I divide by 3 over 2 times the coefficient of the x, which is 2, plus the constant of integration. Now tidying this up, I'm going to have 2x plus 4 raised to the 3 over 2 over 3 plus c, which I could just write as 1/3, and we could actually put it back in a radical form. So I could say the square root of 2x plus 4 cubed plus c. And there we go for question B. Now in question C, whatever variable we're going to integrate must be in the numerator. So my first step will be to bring up the function in my denominator. So I'm going to have the integral of 6. And of course the 6 could go outside the bracket if we want. So let us put it out there. So we can put the 6 out here. Now when I bring up the function, I'm going to have 4x plus 1 all raised to the minus 2 dx. We'll go right ahead and we integrate. So we have 6 times, if we add 1 to that power, I'm going to have 4x plus 1 to the negative 1 all over negative 1 times the coefficient of the x, which is 4 plus c. Now we don't want to leave it like this, so we can simplify this. This will become 6 over negative 4, which I can just say negative 3 over 2. We have 4x plus 1 raised to the negative 1 plus c. And of course, if I wanted, I could bring this down. So I could say negative 3 over 2 times 4x plus 1 plus c. And of course, I could actually expand the bracket here because the power of the bracket is now equal to 1. So if you want, you could take it one step further. All right? So we have to learn to manipulate the function sometimes to integrate them.